All right, let's jump straight into this explainer and unpack a truly revolutionary architectural blueprint, one that literally merges digital and physical engineering. If you're a scientist, a systems engineer, or a hardware architect, you are definitely going to want to pay close attention to this. We're looking at the OMI Object Model. It's a protocol that fundamentally redefines exactly how we think about state, agreement, and physical computing.
Now, you might be wondering, what if the entire web and the physical world shared just one verifiable instruction set? I mean, this poses the absolute ultimate systems engineering challenge, right? Because for decades, we've been stuck building these fragmented, closed-world silos. Your data in one app doesn't seamlessly translate to a physical sensor, and that sensor doesn't talk perfectly to an optical network. But what if we could actually move beyond all that? What if we had a truly universal mathematical foundation that seamlessly operated across every single one of these domains?
Well, to actually achieve that, we have to start way down at the bit-level atomic unit. This right here is the foundation of the whole protocol, a palindrome. It's OMI read forward and MO read backward. Represented by the lowercase and uppercase Greek letter Omicron, these act as your low and high anchors. They physically frame every single transmission cycle from a low input to a high output. Think of it kind of like an unbreakable, mathematically sealed envelope. Literally nothing enters or exits without passing through this bidirectional validation gate, and it's always enclosed in exactly 128 characters.
So why go through all the trouble of this strict framing? Well, because of what consumers actually expect today. People expect their data to seamlessly move from opening and browsing all the way to verifying, sharing, and replaying without getting trapped in some weird ecosystem. Users don't want to learn the ins and outs of a complex protocol. They just want to interact with objects that perfectly retain their context no matter where they go.
To fix this whole broken, siloed experience, we have to bridge a massive gap between closed-world and open-world systems. In a closed world, a single app owns the database, it owns the object ID, and it owns the ultimate truth state. It's basically a dead end. But in the OMI open world, an object actually has a portable, inspectable structure. It maintains its absolute integrity across any portal, whether we're talking about a web browser, a QR code, or a physical microcontroller. So here's our quick roadmap for this explainer. We'll be hitting the universal palindromic blueprint, the mathematics of OMI, bare metal systems engineering, bridging digital and physical, agreement as validated topology, and finally wrapping up with the future for engineers. Let's get right into it.
Section 1. The Universal Palindromic Blueprint.
Check this out. Every single object in this ecosystem is strictly bound inside this one perfect long-word instruction. It's totemy, then the payload, then IMO. And it really doesn't matter if you're an engineer working with a DOM node, generating an offline receipt, or even programming a robot's physical intent. Every piece of state is enclosed in this exact verifiable boundary. It acts as the ultimate escape sequence that hardware scanners can pick up and detect instantly.
Section 2. The Mathematics of OMI.
Now, this is where the engineering gets absolutely fascinating, especially for the scientists mapping physical space. The entire OMI spatial geometry is governed by one binary quadratic form. By treating code as literal physical architecture, this quadratic law maps the high plane ID directly to the low plane atomic data. And take a look at that first coefficient, 60. It uses a Base-60 sexagesimal system. Why 60? Because it's a highly composite number. This guarantees that when you subdivide coordinate space, you literally never produce fractional truncation errors. That means flawless precision without any of those annoying floating point rounding errors. And working right alongside that quadratic law is the delta law. This is a branchless, period 8 engine that completely bounds state to a 16-bit width. It relies purely on bitwise rotations and XOR operations. What does that mean for us? It means absolutely no bits are ever lost, and the entire process is fully reversible. This exact math ensures every valid pointer pair forms a convex space with 0 saddle points. In plain English, it acts as an unbreakable structural checksum for the whole system.
Moving on to Section 3. Bare metal systems engineering.
Okay, systems engineers, you are going to absolutely love this number. 5040. Memory in OMI is designed as a lock-free, atomic circular buffer that is exactly 7 factorial slots long. That's 5,040 slots. By structuring memory exactly like this, the protocol completely eliminates the need for slow mutex locks or complex garbage collection. It's just an atomic cursor moving gracefully through a mathematically perfect loop. No traffic jams, no locks whatsoever.
So at the hardware level, this validation is incredibly fast. Just imagine an eBPF filter sitting at your network interface card. It validates every single incoming IPv6 packet through these exact 3 steps. First, a branchless check of that quadratic surface. Second, a final loop resolution strictly capped at 15 steps. And third, writing the receipt straight into that 5040 slot ring. It does all of this before the data even touches user space overhead. Invalid frames? They're simply dropped. It is ruthless, mathematical efficiency at its finest.
Which brings us to Section 4, Bridging Digital and Physical. Hardware developers, listen up, because these are your new tools to bridge the divide. OMI GPO acts as the transliteration layer. It actually turns physical voltage directly into protocol agreement. It lets a cheap microcontroller read a sensor, verify an OMI frame, and take action. Then you have OMI Matrix, which uses barcodes as optical memory surfaces, and OMI Gnomon, which uses light fields to synchronize orientation. You are literally turning symbolic logic into physical pulses without ever losing a drop of structural integrity.
And to actually make that light field sync work in the real world, we lean heavily on this exact OMI formula. This right here is the missing geometric constraint that allows completely independent optical computing devices to share space and time. It gives every single object a light field incidence structure. We're talking 8 chiral vertices and 6 relational planes. It allows independent objects to perfectly align inside what the protocol literally calls wormhole portals. I know, it sounds like straight-up sci-fi, but it is pure, shared optical reality.
Section 5, Agreement as Validated Topology. Okay, so let's completely flip how we view disagreement for a second. Under this protocol, disagreement is no longer a systemic failure. It just isn't. It is simply unallocated entropy, its missing structure. The protocol dictates that this missing structure just has to be routed constructively into a new object, a new path, a new test, or a new receipt.
And this whole beautiful process is managed by the OMI neat layer, which stands for Neuro-Evolutionary Augmented Topology. It ensures that the human observer isn't totally overwhelmed by network noise. It balances the entropy by allocating only the appropriate structural steps needed for a frame to smoothly move through its environment. It basically turns raw, chaotic disagreement into beautifully validated topology.
And finally, Section 6, the future for engineers. For the scientists, hardware architects, and robotics developers tuned in, this is your exact operational path moving forward into the future of computing. You start with abstract symbolic intent. You orient it via light fields. You map it to an optical carrier. Then you execute it via physical transduction, like through a GPIO pin. And you end with a perfectly mathematical, replayable receipt. It completely bridges the mind of the machine with the physical light of the real world. Which all leads us to this absolutely profound rule. AGI intent must become Omicron agreement before becoming physical action. Think about it. If we are going to safely deploy artificial general intelligence into physical robotics, we desperately need a hard boundary. A robot must decode a signal, verify the Omicron enclosure, and validate the math before it ever moves a motor. This protocol provides that exact, mathematically rigorous safety boundary.
So, I'm going to leave you with this question to chew on for your next project. Whether you're a scientist writing low-level kernel filters or an engineer designing the next generation of optical hardware, the future of engineering relies on objects that don't just render on a screen, but permanently and mathematically agree out in the physical world. How will you engineer differently when you possess this shared physics? Thanks for diving into this explainer with me today.